Yeah. So can you just confirm me you are able to see my screen, whether you are able to see my screen and hear me, right? Okay. Yeah. So today we will be discussing about different types of ESP32s. Okay. There are different variants like C2, C3, and we have C5, C6. So like that we have different variants of ESP32s. Okay. So but before going to difference between ESP32 and ESP36, different kinds of ESP32s. First, we need to know about difference between ESP8266 and ESP32. Yeah. So first, we will be discussing about difference between ESP8266 and ESP32. So actually, ESP82 is having only single core. Okay, whereas ESP32 is having dual core. So if you are if any microcontroller is having multiple cores, it means like you can assign a particular task to be executed in one core and few tasks to be executed in another core, so that we can reduce the latency. Because if you are having a single core, so automatically there would be some internal scheduler. Okay, so after one instructions got executed, again the next instruction would get executed. But if you are having multiple cores, you can split the work, assign one different works to different cores, so that all the works will be executed at a time simultaneously. Okay, ESP32 is having dual core. Yeah. So first we will be discussing about difference between ESP8266 and ESP32. Then we will jump into different kinds of ESP32s. Like we have ESP32 C2, C3, C5, C6. So like that we are having many variants. Okay. So you know about microcontrollers and everything. Yeah. Coming to the introduction to ESP8266. ESP82 is sometimes we call it as ESP8266, or sometimes simply ESP82. So ESP82 is a low-cost microcontroller with integrated Wi-Fi capability. It became extremely popular among hobbyists and engineers because it made wireless projects affordable and easy to build. So even it is very cheaply available, than even ESP32. ESP32 is little bit expensive than ESP82. Let us check the prices as well. So ESP32. Uh, ESP32 or else ESP32 C5. I'll check for C5. Something like 764. So if I just type for ESP8266 CH340 184. See, the price is like there's a huge difference. So yeah, from this we can understand that ESP8266 is very cheaply available. And one more thing, do you know what's the other name for ESP8236? 8266. Anyone? We are having some special name, right, for ESP8266. Anyone? Any idea? What's the other name for ESP8266? No idea. Anyone? Okay. So we simply call it as Node MCU, right? Always we don't say I'm using ESP82, ESP8266. We usually call it as Node MCU. So you might have seen somewhere else like many people are calling Node. I have a Node MCU. So ESP8266 we usually call it as Node MCU. Even other ESPs like ESP32, usually we won't refer them as Node MCU. Whenever anyone use the term, I have a Node MCU. Usually, we referring it to ESP8266 only. Okay, so ESP8266 is commonly called as Node MCU, and it is very low cost microcontroller, and it is having integrated Wi-Fi capabilities. So with the introduction of ESP modules, Espressif company, which manufactures all these ESP modules, So before Espressif company came into the picture, so making wireless controlled projects was little bit extremely difficult. So we are having RF modules. By the time before the introduction of the ESP modules, by that time itself, we are having RF modules, radio frequency modules. But with RF modules, there are so many drawbacks, like we cannot, it is having very limited range, and there are so many drawbacks with RF modules. So with the introduction of one CSP modules, node MCUs, all these came into picture. So integrating Wi-Fi capabilities, Bluetooth functionality, so all these become super easy. So people always started using, ESP modules. So coming to ESP8266, it is having single core processor. I told already. So ESP32s usually have dual core, two cores. Whereas coming to these node MCUs like ESP8266, they have single core. So they have built-in Wi-Fi, and they usually consume low power. So they are built for low power consumption, and the cost is also very low. As we checked earlier, ESP32C5 is something greater than 700, whereas this ESP8266 is something like 176, 186 like that. So less than 200. Okay. So it is having compact design. So it is having single core processor, built-in Wi-Fi, low power consumption, low cost, and compact design. So it is very, we can afford it very easily. And coming to ESP32, so ESP32 is the successor of ESP8266 in the entire ESP family. So the Espressif company started doing advancements, right? So they started introducing many ESP modules. So this ESP32 is the successor of ESP8266 and offers significantly more performance and features. It was designed to handle more complex projects while maintaining low cost and low power consumption. And the ESP32 includes both Wi-Fi and Bluetooth capabilities, making it one of the most versatile microcontrollers available. Okay, it is one of the most versatile microcontroller available. Ibrahim, yeah. So ESP32 is the successor of ESP8266 in the entire ESP family, Espressif family, and it offers significantly more performance and features as well, and it is designed to handle more complex projects while maintaining low cost and low power consumption. So let's see the main features of ESP32. The first one, which is very important, is that it is having dual core processor, whereas ESP82 is having only single core processor. Since it is having a dual core, so that's why it is able to do more complex calculations, or else activities, complex tasks. So if someone asks you why ESP32 can do complicated tasks than the ESP82, ESP8266, because then you need to answer it is having dual core processor. So if you are having multiple cores, you can split the work. So rather than it's like we are having two engines. So rather than relying on only one engine, we are having two, something like two jet engines. So which accelerates the work. So you will be reducing the burden on one core. If you are doing entire work on only one core, it will the core will undergo some stress, right? But if you split the work and assign some work to one core and partially the another whatever the task that is remained, so you can assign a partial work to another core. So when you split this work into and assign it to two, multiple cores, then the burden on each core will reduce, and each course can do any particular task simultaneously. Okay, there is no latency, so all cores can work simultaneously. That's how you will be reducing the time of execution, that which we call it as the time complexity, and then we are increasing the efficiency, but still we are maintaining the low power consumption. Okay, and we are reducing the burden on each core. So now the processing power has been increased. When we compare with the ESP82, the processing power is increased. And just like ESP82, this one is also having built-in Wi-Fi capabilities. And more importantly, this ESP8236 is not having BLE. It's not a BLE, Bluetooth Low Energy Device. It's not come under BLE. Whereas ESP32, it is having Bluetooth functionality as well. That's only one of the important thing. It is having dual cores, and along with Wi-Fi capabilities, it is having Bluetooth functionality as well. And ESP82 usually have some less number of GPIO pins, general purpose input output pins. In ESP32, we can find few more GPIO pins. Let's say if your project requires more number of GPIO pins, then you can go with ESP32 because it is having more GPIO pins, and additionally you are getting one core extra, right? And you are having Bluetooth functionality. No need to use external Bluetooth modules as well. So that's why this is considered as one of the most versatile microcontroller. Okay, the most versatile microcontroller. So coming to the processor comparison, so ESP, someone still trying to join late. Yeah. So we are continuing the discussion about the difference between ESP8266 and uh, ESP32. Okay. Now we are doing the processor comparison. We already done that. What are the main features of ESP32 and ESP8266? We discussed ESP8266 is having single core processor, built-in Wi-Fi, and it is low power consumption, low cost, and compact design. And ESP32, it is having dual core processor, built-in Wi-Fi, but it is also having built-in Bluetooth as well. And it is having more number of GPIO pins compared to ESP82. ESP32 is having more number of GPIO pins. Kindly please mute yourself. Yeah, thank you. Now we are doing the processor comparison. So in processor comparison, first the CPU type. As discussed earlier, ESP82 single core, whereas ESP32 is having dual core. Coming to the clock speed is one of the very essential parameter. Whenever you want to use any kind of microcontroller architecture in your project, first thing that you need to consider is the clock speed. Okay, so it is very essential parameter. Yeah, you need to check how many cores it is having. Along with that, you need to check what is the clock speed. If clock speed is high, we discussed even in PCB sessions, Arduino sessions, Arduino for beginners, and then we also discussed about clock speed in different batches, right? In different courses. So clock speed is very essential parameter. If the clock speed is high, then the rate of data transmission would be high. Okay, it is directly proportional. The more the clock speed is, the more fast of exchange of information. Okay, so clock speed is something which determines how fast the instructions are getting executed. Whatever the program that you are writing in embedded C and uploading it into the microcontroller, so how fast the instructions needs to be executed, it is determined by the parameter clock speed. Okay, in the ESP32, ESP8266 is having 80 to 160 megahertz clock speed. You can adjust. Okay, so there are different modes depending upon, like we have a sleep mode, fast mode, like that. Depending upon the mode, you can adjust the clock speed. Whereas in ESP32, it is having up to 240 megahertz, 240 megahertz frequency. And I repeat, all ESP32 modules do not have same clock speed frequency. We will see, let's say ESP, even in ESP32, we have C2, C3, C5, C6. So different variants will have different clock frequency. Okay. But as of now, overall comparison, like ESP32s can support up to 240 megahertz of frequency, clock speed frequency. And architecture, coming to the architecture, both are built under 32-bit architecture. So can someone just tell me what's the architecture for Arduino UNO? If ESP32 is 32-bit architecture, then what's the architecture for Arduino UNO? Anyone? Arduino UNO, very simple module, right? We use for blinking LED. The very first example that everyone teaches is blinking an LED. So what's the architecture of Arduino UNO? Is it 32-bit or 64-bit? 8-bit, perfect. So it is 8-bit. So whereas ESP32s or else ESP module, all ESP modules are 32-bit processors. They have 32-bit processors, okay, dual core processors. So it is 32-bit, whereas Arduino Uno is just 8-bit. And yeah, coming to the RAM, coming to the memory. So ESP8266 can store up to something like 160 KB, whereas ESP32s are having the RAM storage of 520 KB. Okay, and coming to the flash memory. So what's the flash memory? Any idea what is the flash memory? What's the another name for flash memory? Another name for flash memory. We also call it as program memory. Okay, flash memory we also call it as program memory. So Arduino Unos are 8-bit architecture and ESP32s are 32-bit architecture. All ESP modules, no matter you are using ESP8266 or else ESP32 module. Okay, so usually they are 32-bit architecture. And coming to the flash memory, so you are having of yeah. No, one more question. What's the flash memory of Arduino Uno? For Arduino Uno, what's the flash memory? Any idea? No one. What's the flash memory? Program memory. Program memory is something in which is inside the microcontroller, main microcontroller, where your entire instruction, whatever the program that you are writing in embedded C, will be stored over there in the microcontroller, in the program memory or flash memory. Yeah, Ibrahim, you want to say something? So those who attended the Arduino session, they know about it. Yeah, you are able to hear me, right? So these are the parameters of Arduino Uno module. Okay. So however, the session is not related to the comparison of Arduino Uno module with ESPs, but still it's very essential to understand. So Arduino Unos are 8-bit processors. So whereas coming to the ESP modules, they are 32-bit processors. Okay. So it is only 8-bit processor. And if you just check the clock speed, it's so 16 megahertz. Okay. Clock speed is 16 megahertz. And flash memory is just 32 KB. It's just 32 KB only. See, very small, isn't it? So now if you check for ESP8266, it's 4 MB. For ESP32, it's more than 4 MB. Okay. But here, not even 1 MB. Flash memory is very small, just 32 KB, not even 1 MB. Okay. It's just in KB, not even 1 MB. Clock speed is, if you just check the clock speed, it's 16 megahertz. Coming to our ESP modules, okay. See how huge difference, how huge variation is there between ESPs and the Arduino Uno. So for ESP8266, it's usually the clock frequency is usually something like 80 to 160 megahertz. For ESP32s, something like 240 megahertz. But for Arduino Uno, just 16 megahertz frequency. That means it can execute instructions very slowly. Okay, and flash memory is also very limited. The memory, the size, the storage space allocated, the memory space allocated for storing your program instructions inside ATMega328p microcontroller, which is present in Arduino Uno, is very limited. Just can store up to 32 KB, but here we can store up to 4 MB. Okay, so that's the important thing. So that's why many people started switching to ESP modules. The reason is that ESPs are having, they are built under 32-bit architecture microprocessor. So if you want single core is available. If you want to use double core, dual core, you are having dual core technology, dual core processors are available. So different frequencies you can adjust between 80 to 160 megahertz. And in ESP32s, we are having different variants. Different variant will have different clock frequency. We are having Wi-Fi functionality. We are having Bluetooth functionality, at least for ESP32, keeping 8266 aside, isn't it? And we are having high clock frequency. So that's why people are falling back to ESP modules rather than Uno. Uno is very minimal. That's the starting point to get into the embedded systems. So if you start exploring, you need to begin with the Yonos, and then you need to go to ESPs. You are having intermediary, you are having so many things. You are having Raspberry modules. Even in Raspberry, you have different variants, right? Raspberry Pi Zero W. There are different variants. The latest version, we are having Raspberry Pi 5, and then we are having something like STM microcontrollers, isn't it? We are having FPGA, field programmable gate arrays. Xilinx FPGA. There is so many things in embedded systems. It's the starting point. Arduino Uno is like starting point. So ESP32 or ESP modules are far better than the UNOs. Okay, because they can handle many tasks simultaneously. Yeah, and we already discussed that ESP32s we are having many GPIO pins. Okay, in ESP82 we are having only around 11 usable GPIO pins. I'm not about talking about all GPIO pins, usable GPIO pins. Whereas in ESP32s we are having more than 30 plus usable GPIO pins. Okay, so if you require more number of wirings, you need more number of GPIO pins for your project, general purpose input output pins. Go with ESP32, not ESP82. Okay, and you are having ESP32 is having high clock frequency 240 megahertz, dual core processing, 30 plus more number of usable GPIO pins, having Bluetooth functionality which is absent in ESP82. Yeah, we will discuss about these ADCs, analog to digital converters, and these PWM pins about later. So how this thing works. So basically, ESP8266 is lacking one important feature. Okay, what's that? What's the one important feature which is not present on the left side of this particular table? So just observe and you just let me know. I'm just magnifying the screen for your visibility. So what's the few things which are absent on the left side? I square C. Yes, I square C is absent on ESP8266. And what else? One more thing is also absent. In ESP8266, we are having analog to digital converters. Okay, we are having analog to digital converters, but we are not having digital to analog converters. That's the important thing. Whereas in ESP32, we are having both ADCs and DACs, and we can convert an analog signal into digital signal, and we can again convert a digital signal back into an analog signal. So it's like a two-way processing. If you are having an analog signal, you can convert into digital. If you are having a digital signal, you can convert into an analog output. Okay. But whereas in ESP8236, if you can convert only an analog signal into a digital signal. So there is no interface provided for the conversion of a digital signal into an analog signal. Okay, that's a very important thing. ESP32s can convert any signal into any form. That could be analog to digital or else digital to analog. Whereas ESP8266 can convert only analog signal into digital signal, but cannot again convert a digital signal back into analog signal. It cannot produce an analog output from a digital waveform. Okay. So progressive with modulation pins are common. Even PWM pins are found on Arduino Uno itself, right? So we are having many PWM pins on Arduino Uno. I'll show you that. So there is no amazement of finding PWM in ESPs because Arduino Uno very minimal module itself is having many progressive PWM pins, progressive with modulation pins. Here you can see all these pins, pin number 11, pin number 10, 6, 5, 3. So these are progressive with modulation pins, right? So we are having 3, 5, 6, 9, 10, 11. Okay, those are PWM pins, progressive with the modulation pins. So there is no any amazement. So there is no scope for amazement for finding PWM on ESP module because even the minimalistic Arduino Uno itself is having PWM. So, but the important thing is like that we need to understand ESP82s can support SPI communication. Okay, so in SPI, we will be using pins like a master out, slave in, master in, slave out, right? These kind of pins. But whereas in I2C, we will be using serial clock and serial data. We already learned that I2C, which is part of TWI. TWI means two-wire interface. It's a part of TWI, two-wire interface. Just with the help of two wires, serial clock and serial data wire, we can send and receive signals, transmit and receive the signals. So it's a two-wire interface, I2C, inter-integrated communication protocol. So I2C is absent on ESP8266. Along with I2C, DAC, digital to analog converters are also absent. Okay. Yeah. So let's come to the power management. So many IoT devices, okay, usually multiple modes like a light sleep, deep sleep. Okay, so just for the optimization, let's say your ESP module is not require not having huge work on it, then it will jump into sleep mode. So in sleep we are having two different sleep modes. One is light sleep mode and another one is deep sleep mode. So how to choose these sleep modes can be uh, you know chosen programmatically as well. Okay, so we can choose the sleep mode programmatically as well, which we will see in the embedded C program in the upcoming session. How to make an ESP module to enter into a sleep mode through programmatically. Okay, so both ESP8266 and ESP32 can support sleep modes. So the main idea of a sleep mode is the battery, reduce the power consumption. And if you are working on battery powered systems, so we need to do some battery optimization. Okay, that's the main concept behind the sleep mode, in introducing the sleep mode in expressive modules. So the first thing is to reduce the power consumption whenever the device is in idle state. That means it's not functioning.